Good day, everyone. So today we're going to be looking at Le Chatelier principle. So Le Chatelier principle, okay? So his principle tells us that when a stress is applied to a chemical system at equilibrium, the equilibrium will shift to relieve the stress. That is what Le Chatelier principle tells us. So let us now state Le Chatelier principle. So if on a question you're asked to state Le Chatelier principle, this is what you tell them. Le Chatelier principle states that if a change is made to a system in equilibrium or at equilibrium, the system alters to oppose the change to reestablish equilibrium. So we were at equilibrium and now we're no longer at equilibrium. So the system is now going to do something to reestablish equilibrium. That is Le Chatelier. So here we have a practical example. All right. So everybody knows that sometimes we eat certain foods and it raises our blood level, our blood sugar levels. Okay. And sometimes we haven't eaten and our blood sugar level is low. Okay. So that is not the norm. Okay. Because we have a normal blood sugar level, right? Does anybody know what the normal blood sugar level is? Good. So what is happening is if your blood sugar level is too low, your body is going to be releasing this thing called glucagon. And glucagon is going to be increasing your blood sugar level. If your blood sugar level now is too high, your body is going to be releasing insulin, and the insulin is going to help to lower the blood glucose. So equilibrium is the blood is either too high, the blood sugar level is either too high or too low. So your body now needs to do something to oppose that change so that it can reestablish equilibrium. Okay? That is what Le Chatelier is all about. Reestablishing equilibrium. Okay? Due to changes. What is referred to as the forward reaction. So the forward reaction, this is the reaction that proceeds from left to right. So let's look at it. A and B is moving. So we have A and B, right? Producing, so starting with A and B, which is on the left, you have an arrow to give you C and D on the right. So it's moving forward. So we call it the forward reaction. Okay? There's also another name that we can give to this reaction. We can also refer to it as the right reaction. Why do you think the right reaction? Because the arrow is pointed to the right. So two names for it. Forward because the reaction is proceeding from left to right, or we could refer to it as the right reaction because the arrow is pointing to the right. Easy. And the backward reaction, this is the reaction that is going to be proceeding from, very good, I said it, from right to left. So look at it. So C and D now giving you A and B, and D is on the right, A on the left. So that's the backward reaction. The backward reaction is also referred to the left reaction because the arrowhead is pointed to the left. Okay, that's it. So now we have this term called reversible reaction. So when a reaction occurs both forward and reverse direction, it is called a reversible reaction. So you have reaction that's occurring both forward and backward. So let's look at this. Sulfur dioxide and oxygen to produce sulfur trioxide. This is our step 2 in the which process? Contact process, all right? So that second process has a reversible arrow. So let's look at it now. So you have sulfur dioxide plus oxygen to produce sulfur trioxide. That is forward or backward reaction. That's the forward reaction. Good, because it's going from left to right. Good. Now what about sulfur trioxide, the back arrow? Look at it. Sulfur trioxide to produce oxygen and sulfur dioxide. Is that going backward or forward? Backward. So that is the backward reaction. Good job. Now, the next term we have here is chemical equilibrium. At chemical equilibrium, what I want you to note is that the rate of the forward reaction becomes equal to the rate of the backward reaction. That is what we mean by chemical equilibrium. So the rate, we know that rate is going to be the time, that the speed at which these particles are reacting. Okay, so the reaction that's happening in the forward reaction and the reaction happening at the backward reaction, they're both happening at they're happening at the same pace, the same speed. Okay, and that is what we mean by chemical equilibrium. The speed is the same for both forward and backward reactions. Now we have the reaction in favor. What does that mean? It just means that the reaction is sped up in a particular direction until equilibrium is restored. That's all that means. One side of the reaction is going to be sped up, and it's going to be sped up just until we restore equilibrium. That's it. Okay, got that?